Welcome to The Explainer. Our planet is just humming with these incredible unseen energies. So today, we're going to dive into three of its most baffling mysteries. We're talking about phantom fireballs, these ghostly lights way up in the atmosphere, and a really strange rhythmic pulse that's coming from deep inside the Earth itself.
So, we're going to start our journey right here on the ground. Then we'll shoot all the way up to the edge of space, and finally, we'll dive deep into the planet's crust. We're on a mission to uncover three incredible enigmas that, honestly, they completely challenge what we think we know about the world around us.
All right, first up, the ball lightning enigma. So, our first mystery, it looks like a floating ball of light. It's called ball lightning, and get this, for centuries, it has just completely baffled anyone who's seen it with its totally bizarre and, frankly, impossible behavior.
Okay, so the real puzzle with ball lightning is all the contradictions. I mean, people see it in perfectly clear skies and in the middle of a thunderstorm. Sometimes it just hangs there, motionless, and other times it zips all over the place. It might just poof, disappear quietly, or it could go out with a massive explosion. You can see why it's a total physicist's nightmare, right? It just seems to break all the rules we thought we knew.
And, we're so lucky to have detailed accounts like this one from a chemistry specialist, M.T. Dmitriev. I mean, this guy wasn't just some random person on the street. He actually had experience with plasma. So his description, it gives us this incredibly rare glimpse into the structure of these things. He talks about a bright, hot core, then a violet layer, and then this fading blue outer shell. Just amazing detail. So how in the world could something like this even exist? Well, the leading theory is something called the electron ionic model. And it basically imagines ball lightning as this tiny, stable bubble of plasma. So try to picture this. A shell of electrons is spinning so fast that it creates its own magnetic field. And that field is strong enough to trap a core of superheated charged air. It's like holding a piece of a lightning strike in a perfect, stable ball. Wild, right? And this table here really shows you just how much power these things can pack. I mean, a tiny little 1 centimeter ball, yeah, that's pretty harmless. But scale that up to about 17 centimeters, and suddenly you're looking at over 10,000 joules of energy. To put that in perspective, that is more than enough to melt metal or literally blast through a door. And that goes a long way to explaining some of those really dramatic eyewitness reports you hear about. All right, section 2, lights above the storm. So we're leaving the ground and heading way, way up high above the clouds. Because up here in the upper atmosphere, thunderstorms are actually powering this spectacular, almost secret light show. It's a whole family of lights that, incredibly, were only just recently discovered. And listen, these aren't just some random flashes of light. No, they're a whole class of phenomena called transient luminous events, or TLEs for short. Think of them as massive electrical discharges. But the thing is, they happen so high up, and they're over so fast that for pretty much all of human history, we had no idea they were even there. So within this atmospheric family, there are really three main types. First up, you've got sprites. These things are huge, red, jellyfish-looking flashes that can be like 50 miles tall. Then you've got blue jets, which are pretty much what they sound like, lightning bolts that shoot upwards from the tops of clouds. And finally, there are elves. These enormous expanding rings of red light that form right at the very edge of space. And what's so cool is that a huge amount of what we know about these things, it doesn't come from giant professional observatories. Nope. It comes from dedicated citizen scientists, people like Paul Smith. These are photographers who spend night after night hunting for these split-second flashes, and their work has been absolutely crucial in showing us just how varied and beautiful TLEs really are. Okay, so of all the different TLEs, elves are probably the ones we understand the best. Here's how it works. A really powerful lightning strike happens, and it sends out this electromagnetic pulse. Think of it like a ripple in a pond, but spreading out at nearly the speed of light. Now, when this pulse gets up to about 90 kilometers, it smacks into a thin layer of nitrogen molecules, and that impact makes them glow red for less than 1,000th of a second. So that expanding ripple cutting through the nitrogen layer, that's what creates the amazing ring shape that we see. And as if sprites, jets, and elves weren't already mind-blowing enough, in 2019, yet another type of TLE was discovered, and it has the best name, ghosts. These are these faint green glows that last for just a millisecond and appear right above sprites. And what's really amazing is where that green color comes from. It's excited oxygen atoms, sure, but it's also mixed with traces of iron and nickel from meteor dust burning up in the atmosphere. How cool is that? All right, time for our final mystery. And for this one, we're leaving the sky behind. We're going to turn our attention to something completely invisible. It's a steady, rhythmic pulse, and it's coming from deep, deep within the planet itself. So check this out. For more than 60 years, these super sensitive seismometers all around the world have been picking up this signal. It's a tiny, tiny seismic tremor that repeats, like perfect clockwork, every 26 seconds. Now, it's way too faint for any of us to feel, but it's always there. A constant, planetary heartbeat. This thing was actually first detected way back in the early 1960s by a geophysicist named Jack Oliver. But, the technology back then just wasn't good enough to really study it properly, so it was kind of forgotten about for decades. That is, until 2005, when modern equipment not only confirmed, yep, it's real, but it also pinpointed its source to a very, very specific location on the globe. So now we know the where. It's coming from a region in the Atlantic Ocean called the Bight of Bonny, right off the coast of West Africa. But the why? Well, that is one of the biggest unsolved mysteries in geophysics today. I mean, what on earth could possibly be causing such a tiny but perfectly regular tremor? Right now, there are two leading ideas. The first one is actually surprisingly simple. It might just be ocean waves. The theory goes that as waves constantly pound the continental shelf in that one specific area, they create a steady, rhythmic vibration. The second theory points to a volcano. See, the pulse originates really close to an active volcano on the island of São Tomé, so it's possible it's being caused by the regular movement of magma deep underground. But for now, the jury is definitely still out on this one. So, to recap, an unsolved symphony. We've gone from a tangible fireball that seems to defy the laws of physics to this ghostly light show high up in the heavens, all the way to an invisible planetary pulse from the deep. I mean, these incredible phenomena are just such a powerful reminder of how dynamic our planet really is, and man, how much we still have to learn. When you think about it, each one of these enigmas just pushes the boundaries of what we thought we knew, scientifically speaking. They force us to look closer, to dig deeper, and to recognize that our world is constantly humming with these active, unseen energies, operating on scales that, honestly, we're only just beginning to wrap our heads around. And so the quest to solve these puzzles continues, driven by both professional scientists and curious citizens, which is awesome. And it really just leaves us with one final fascinating thought to chew on. If these things are happening, what other profound secrets is our planet hiding from us? Right here, in plain sight.